Life on the Ring of Fire is defined by constant geological tension. By 2025, monitoring systems continue to measure steady activity across the zone. Volcanic clusters, earthquake swarms, and tremors rarely stop, even if many of the events remain small. Sensors register pulses of energy deep underground that rarely make the news but point to vast pressure locked beneath the crust. For people living there, these signals are not abstract. They serve as reminders that eruptions, quakes, and tsunamis are an ever-present possibility. What makes the Ring of Fire even more critical is the scale of communities built directly on it. Megacities like Tokyo, Manila, and Jakarta sit squarely in hazard zones, housing tens of millions of residents within reach of active volcanoes and fault lines. People remain because the benefits are undeniable. Fertile volcanic soils produce crops, coastlines provide shipping routes, and mineral-rich terrain supports entire industries. Opportunity and risk are fused together, making life along the Ring of Fire both precarious and productive. This balance is fragile. The same tectonic forces that enrich soil also shake cities, and the same seas that fuel trade can deliver tsunamis in a matter of hours. The Ring of Fire shows how geography can define human life more powerfully than borders ever could. And while here the ground itself is unstable, other parts of the planet reveal equally striking stories hidden not in fire, but in water held in remarkable concentration. The world's deepest freshwater treasury. Deep in Siberia lies one of the planet's most important natural reservoirs, Lake Baikal. Often called the Pearl of Siberia, it holds one of the largest single reserves of unfrozen freshwater on Earth and also claims the title of the deepest lake, plunging more than 5,300 feet. This immense depth makes it a global treasury of freshwater, unmatched in scale and importance. Few people may ever see it firsthand, but Baikal is a resource on which much of the world's balance quietly depends. Its records do not end with depth. Baikal is also among the oldest lakes known to science, with origins stretching back at least 25 million years. While empires rose and fell across Eurasia, Baikal remained in place, collecting sediments and fostering life across unimaginably long spans of time. This enormous age has given the lake the rare ability to preserve ecosystems over evolutionary timescales, offering scientists clues about how species adapt and survive under changing conditions. Over that timeline, Baikal developed a biodiversity found nowhere else. More than half the species in its waters exist only within its basin. The Baikal seal, or Nerpa, is the world's only exclusively freshwater seal. Fish such as the oilfish and unique forms of crustaceans fill its depths, while microscopic organisms support the food web in specialized layers shaped by depth, temperature, and oxygen content. For researchers, Baikal functions as a natural laboratory, an aquatic world where evolution played out in isolation, protected by geography and the self-contained nature of its basin. Yet even here, threats are building. Rising water temperatures stress ecosystems finely tuned to stability, while algal blooms tied to warmer conditions disrupt oxygen levels and alter the food chain. Added to that, pollution from development and industry seeps into places once considered remote. By 2025, new conservation and monitoring programs track these changes more closely, though scientists warn that a lake stabilized over millions of years can still be unsettled in only a few decades. For local communities, Baikal is more than water. It is sacred ground, bound to cultural traditions and histories that treat the lake with reverence. For humanity as a whole, it is an irreplaceable storehouse of knowledge and resources. It stands as proof that Earth's freshwater reserves can be as deep and dramatic as any mountain is high, a reminder of extremes that shape our planet in ways we cannot ignore. And while this is the deepest treasury of freshwater, elsewhere another measure of depth pushes far beyond any lake, plunging to the most extreme depths known anywhere on Earth. Earth's deepest point outclasses Everest. Mount Everest is often used as the ultimate measure of Earth's extremes, standing just shy of 29,000 feet above sea level. Yet the highest peak is outclassed by what lies beneath the Pacific Ocean. The Mariana Trench holds the challenger deep, plunging to nearly 36,000 feet. Put Everest inside, and its summit would still remain far below the surface. In raw scale, this depth goes thousands of feet beyond the tallest mountain's height. The magnitude is striking, but the conditions make it remarkable. At the bottom of Challenger Deep, pressure exceeds 1,000 times what we feel at sea level, enough to crush ordinary vessels instantly. This lightless, near-freezing environment was once assumed to be sterile, devoid of life. Instead, exploration has revealed the opposite. Scientists have found bacteria, extremophiles, and even small organisms adapted to endure the crushing weight of water. These species survive on chemical energy rather than sunlight, extracting nourishment from elements such as methane or sulfur. Their existence proves that life can persist under conditions previously thought impossible, forcing us to rethink what environments might sustain biology on other worlds. If creatures thrive in the trench without light, similar ecosystems might exist beneath the icy oceans of moons like Europa or Enceladus. Despite these discoveries, reaching the bottom remains rare. Only a handful of manned submersibles have descended all the way down, joining unmanned probes in probing the trench's floor. Each dive collects samples and data that expand our understanding of how geology and biology interact under extremes of pressure and isolation. The trench is not just another geographic statistic. It is proof that Earth's extremes are as much about hidden depth as towering height. What Challenger Deep illustrates is that the planet's grandest records need not always point upward. Sometimes they point into darkness, where scale and survival rewrite assumptions. These deep points remind us that Earth's geography holds constant surprises, shaping how we think about both land and sea. And from these hidden depths, our focus shifts to another frontier, one where surprising closeness challenges the distances we imagine between nations. One state closer to Russia than America. The United States and Russia might seem like continents apart, but in reality, they share one of the planet's closest borders. From the edge of Alaska's western coast, Russia lies just across the Bering Strait, less than 55 miles away. On clear days, the Russian shoreline can actually be seen from American soil. What often feels like a rivalry defined by distance is, in fact, separated by little more than a narrow stretch of water. At the center of this strait sit the Geomed Islands, a striking example of this closeness. Big Geomed belongs to Russia, while Little Geomed belongs to the United States. Only 2.4 miles, or about 3.8 kilometers, separate them. Standing on one, it is easy to spot the landforms and even structures on the other. Yet the water between them is more than a geographic divide, it is a leap in time. Big Geomed sits nearly 21 hours ahead of its neighbor, meaning that gazing across the channel from the US side is like looking into the next day. Few places on Earth condense both space and time separation into such a small distance. Alaska highlights this paradox more than anywhere else. For most Americans, the state feels remote and far-flung, but its far western edges sit closer to Russian territory than to much of the continental United States. A flight from Anchorage to Seattle covers more ground than the water that separates Alaska from Siberia. It looks like the edge of America on most maps, but in practical terms, it is one of its closest points of contact with another major power. This slim distance has long carried geopolitical weight. During the Cold War, the Bering Strait bristled with monitoring stations, radar systems, and military watchpoints, as both nations tracked activity across the border. Today, the region still matters, not only for security, but also as a potential gateway for Arctic shipping routes and resource exploration. Its position between the Pacific and Arctic Oceans ensures that it remains strategically significant, even without a bridge or road to connect the two sides. Geography makes rivals into neighbors, and the line drawn down the middle of this narrow strait is enough to separate two of the world's largest nations. But borders do not always divide so sharply. In some parts of the world, one single waterway does the opposite, linking multiple nations together through a shared and fragile lifeline. The river connecting 11 nations. The Nile River stands apart as the only waterway that links more than 10 nations together under one system. Stretching over 4,100 miles through Africa, it is not just the longest river on Earth, but also one of the most politically significant. By 2025, the Nile Basin supports upwards of 10 countries across Northeast and East Africa, each relying on its waters for farming, fishing, and electricity. This makes the river more than a natural feature. It is a foundation of national security for millions of people. For thousands of years, the Nile has carried immense weight in human history. Ancient civilizations thrived on its seasonal floods, and today its flow still underpins food security and economic survival. But the pressures on it are greater than ever. Rapidly growing populations, shifting rainfall brought on by climate change, and the intensifying needs of modern economies all converge along this same river. Managing those demands across multiple governments, each with its own interests, turns the Nile into one of the most complex shared resources on the planet. The Grand Ethiopian Renaissance Dam is the clearest example of both opportunity and strain. Built in Ethiopia to generate hydroelectric power, it symbolizes progress and energy independence for millions. But downstream nations such as Sudan and Egypt worry about reduced river flow, especially during periods of drought. For them, any alteration to established water patterns threatens agriculture, industry, and access to drinking water. Disagreements over how to manage the dam show how deeply one decision in a single country can ripple across the entire basin. This is the Nile's paradox. It sustains farmers who depend on predictable irrigation, fishing communities who draw their livelihoods from its currents, and national grids that rely on consistent electricity. Yet because it must do so across so many borders, every negotiation becomes a balancing act between cooperation and conflict. When the river rises, it carries hope and productivity. When the flow changes unexpectedly, it risks inflaming disputes. The Nile demonstrates how geography binds together vast regions while straining them at the same time. A river this vital proves that even features that look steady on a map are dynamic, shifting the lives of nations around them. And sometimes, what appears immovable, like an entire landmass, turns out to be slowly on the move after all. An entire continent on the move. Australia is one of the rare places where you can measure continental motion with modern tools. Each year, the landmass shifts northeast at roughly 2.7 inches, carried on the slow but steady movement of the Indo-Australian tectonic plate. It is not something you feel standing still on the ground, but across decades, that drift becomes significant, shifting the country several feet from its earlier position. This migration creates practical consequences. Systems that rely on precise location data, such as GPS, construction surveying, and agricultural planning, cannot ignore even small changes. By 2025, the cumulative drift forced Australia's mapping authorities to adjust the nation's official coordinates so that satellite positioning lined up with reality. Without these corrections, a self-driving tractor guided by GPS might plow in the wrong lane, or engineering projects would risk measurement errors. Something as seemingly abstract as continental drift becomes part of the daily infrastructure of technology. The phenomenon also underscores the restless nature of Earth's crust. Australia lies away from the fault zones that define the Ring of Fire, placing it among the most geologically stable regions on the planet. Yet its steady northeastward journey shows that stable does not mean fixed. The surface beneath towns, airports, and highways moves continuously, even if the changes remain invisible to those living there. Technology companies and government agencies alike account for this motion. Updates to mapping software reflect positional changes, ensuring consistency for everything from car navigation apps to precision agriculture. Research institutions use the data to refine models of tectonic dynamics, learning how continental plates interact on a global scale. What might feel like motion too small to notice is enormous when applied over the span of an entire continent. In contrast to the dramatic eruptions and earthquakes that dominate headlines, Australia's drift is quiet, uniform, and predictable. Yet it demonstrates the same principle. Our planet's surface is never fixed in place. The land beneath us changes position at a pace we cannot sense, but cannot ignore, linking natural processes to the technologies we rely on. And while continents shift on hidden plates, other parts of the world remind us that geography's surprises can also be counted one fragment at a time. The land of islands without end. Finland is not usually the first place people think of when they imagine endless chains of islands. Yet this northern nation quietly holds one of geography's biggest surprises. Finland is home to an extraordinarily large number of islands, far more than almost any other country. Its terrain is among the most island-dense on Earth, shaped into a fractured patchwork of water and land that makes its national map distinctive worldwide. What makes Finland stand out is the scale. It holds dramatically more islands than its Scandinavian neighbors and even surpasses countries better known for vast archipelagos. Indonesia, often recognized globally for its sprawling island chains across the equator, has fewer than Finland when measured by the same criteria. The difference highlights how geographic assumptions can be misleading. Where Indonesia's islands rise from tropical seas, Finland's were carved by glaciers during the last ice age, leaving behind rocky fragments and waterways across northern latitudes. The result is a jagged coast and inland terrain broken into tens of thousands of pieces. This fragmented setting shapes how people live and move. The waterways that thread between islands form natural channels, functioning as highways for fishing, transport, and recreation. In summer, families head to cabins tucked along lake islands or remote coastal inlets, cementing one of Finland's strongest cultural traditions, the seasonal retreat to nature. Tourism builds on the same appeal, with visitors drawn to the experience of boating through the archipelago and stepping ashore on secluded islands. Infrastructure also reflects this unusual geography. Ferries carry cars and people across key straits, bridges link smaller gaps, and many communities remain accessible only by watercraft. For travelers, moving through Finland often feels like weaving a path through a giant puzzle, where every turn opens onto another body of water dotted with forested islands. This interconnectedness between land and water influences daily routines in ways that are rare elsewhere. Despite not advertising itself as the world's island nation, Finland effectively holds that title. It is a landscape defined by fragments, where nature broke the land into scattered pieces and people adapted by building lives among them. But while Finland demonstrates how abundance of land and water can coexist in balance, another region of Earth illustrates geography's influence on a far larger scale, an environment that sustains life everywhere with the air it produces. The planet's green lungs. The Amazon rainforest is often described as the lungs of the planet, but its role is far more complex than a single metaphor suggests. Covering millions of square miles in South America, it is globally critical, massive in size, unmatched in biodiversity, and central to regulating the Earth's carbon and climate systems. While plants in the Amazon do release oxygen through photosynthesis, much of that oxygen is consumed again by natural decomposition and respiration. Its deeper importance lies in absorbing carbon dioxide, stabilizing weather patterns, and supporting an interconnected web of life across the basin. That balance is increasingly fragile. Logging, agriculture, and uncontrolled fires strip away vast areas of forest each year. When trees are cut or burned, the carbon they store escapes directly into the atmosphere, weakening the Amazon's role as a carbon sink and speeding global warming. Scientists caution that if deforestation continues at its current pace, the forest's ability to regulate rainfall and keep regional climates steady may falter. What should act as a safeguard against rising greenhouse gases instead risks becoming a major source of them. The biological richness of the Amazon adds immeasurable weight to its influence. It is home to millions of species of insects, mammals, birds, and plants, many of which exist nowhere else on Earth. This biodiversity underpins the stability of the forest. Every tree and animal occupies a role in maintaining balance, from soil health to pollination. Remove too many of these links, and the system begins to break down.